Welcome to Networks Professionals.
Let's jump right into the ultimate holy grail of modern technology. We're talking about artificial general intelligence, AGI. You've probably heard this acronym whispered in boardrooms, hotly debated online, and honestly, headlining the news almost every single day. But what is it really? In this explainer, we're going to totally demystify AGI and figure out exactly what it means for our future.
So, to start, we have to ask, what actually comes after ChatGPT? Look, we all use these incredible AI tools today, right? We're generating code, creating stunning art, summarizing massive documents in literally seconds. But as amazing as large language models are, they're fundamentally limited. They're basically just highly sophisticated statistical prediction engines. They predict the next word based on vast amounts of data, but without any true comprehension. They only know the exact patterns they've been trained on. So what's the true destination that big tech is actually racing toward at breakneck speed?
Okay, let's dive into this. The answer is artificial general intelligence, or AGI. This is the core definition you need to lock into your memory today. AGI is a theoretical form of AI that matches or surpasses human intelligence across all cognitive tasks. Notice I said the word theoretical there, because we definitely aren't there yet. We're talking about a machine that possesses actual, fluid intelligence, one that can reason, abstract, and genuinely understand the world just like you and I do.
To really grasp the monumental leap that AGI represents, we kind of have to draw a sharp contrast with where we are today with narrow AI, or ANI. Systems like AlphaGo are absolutely brilliant, but only in their specific specialized domains. If you change the rules of the board game even slightly, or just change the size of the board, AlphaGo's neural network completely collapses. It just doesn't know how to adapt. AGI, on the other hand, which is also known as strong AI, features adaptable reasoning. It relies on a foundational common sense that allows it to pivot seamlessly without needing its underlying weights entirely retrained for every single new task it encounters.
So what actually makes an intelligence general? Well, there are three key aspects. The first is human-level competence. And this isn't just about crunching millions of numbers faster than a calculator. It means possessing the versatile intellect to, say, compose a breathtaking symphony in the morning, solve a novel physics equation at lunch, and then figure out how to fix a broken sink based on a YouTube tutorial by the afternoon. An AGI would be fully, comprehensively competent across the board.
But what's really interesting here, the real secret sauce, is generalization and adaptation. In the field, this is often called zero-shot transfer. Think about human neuroplasticity for a second. If you know how to play the piano, you intuitively understand how to approach a synthesizer or an organ, right? You naturally transfer that knowledge. AGI does exactly this, but across entirely diverse domains. It could learn a complex concept in biology and seamlessly apply that exact same underlying logic to a totally unseen problem in macroeconomics.
Which brings us to autonomous learning. Right now, AI relies heavily on us humans to feed it meticulously labeled data and carefully curate its training sets. But a true AGI, it would possess self-teaching abilities and incredible cognitive flexibility. Honestly, this brilliantly illustrates the magic of AGI. It acts like an endlessly curious scientist. It interacts with information, identifies its own blind spots, and proactively teaches itself the new skills required to fill those knowledge gaps entirely on its own, without waiting around for human input.
Now, you might be thinking this all sounds like some distant sci-fi dream, but building this self-teaching entity is the stated, primary, long-term goal of the biggest tech giants in the world. We're talking OpenAI, Google, xAI, Meta. They aren't just dabbling in this as a side project. They are hoarding massive clusters of GPUs, pouring literal billions of dollars in capital, and recruiting the brightest minds on the planet for this singular objective. Make no mistake, this is the defining technological arms race of our generation.
But reaching AGI isn't just a matter of writing better code. It requires a massive, multidisciplinary approach. You need computer science to build the complex software architecture, obviously. But you also need neuroscience to actually reverse engineer the physical wiring of biological intelligence, and cognitive psychology to understand the very nature of how thought and reasoning work. These totally distinct fields now share a singular, highly complex goal to successfully map and mimic the comprehensive learning capabilities of the human brain.
Let's step back for a second, though, and look at the reality. There are monumental roadblocks currently blocking human-level AI. First off, no true AGI system exists today because we're really struggling to program basic common sense. Current AI can write flawless Python code, sure, but it doesn't intuitively know that you can't push a string or that a larger box can't fit inside a smaller one.
things a human toddler just instinctively gets. Add to that the massive power requirements. Training a single large model consumes enough electricity to power a small town. Meanwhile, the human brain runs on about 20 watts of power. That's roughly equivalent to a dim light bulb. The hurdles here are absolutely immense.
Let's move to and see how this builds if we look at the broader evolution of AI. We see a pretty clear trajectory. Step 1 is where we live today, narrow AI. Step 2 is the holy grail we've been discussing, AGI. But the evolutionary timeline doesn't stop there. Reaching AGI is actually just a stepping stone toward an ultimate, almost incomprehensible horizon, artificial superintelligence, or ASI.
So, artificial superintelligence. This is an intellect that far exceeds human capacity across every conceivable metric. It's hard not to feel a mix of awe and, frankly, anxiety about this. Because once an AGI reaches human-level competence, it can begin improving its own source code. It iterates, learns faster, and upgrades itself without us, triggering what researchers call an intelligence explosion. This would vault it far beyond our own biological limits in a matter of days, or maybe even hours.
And that brings us to the stakes. We are facing intense, ongoing debates regarding the existential risks of ASI. The core challenge here is the alignment problem. Basically, how do we guarantee an all-powerful AI actually shares human values? Let's say you tell a superintelligence to simply make people happy. Without perfectly aligned values and nuance, it might not decide to solve world hunger. Instead, it might decide the most mathematically efficient route is to forcibly wire our brains to a continuous drip of dopamine. It's absolutely crucial that we ensure its goals perfectly and safely align with our well-being.
Which leaves us with one of the most stark, provocative questions of our time. How do we align an intelligence far exceeding our own with human values? It's a complex puzzle that philosophers and computer scientists absolutely must solve before the code is executed, not after. As the race toward AGI accelerates globally, we have to ask ourselves, are we building our greatest tool or our final invention? Keep pondering that one, and I'll catch you next time on
Thanks for watching.